Very warm welcome to this year's Innovation Hub hosted by Agri-TechE on behalf of the Royal Norfolk Agricultural Association. I'm Laura Bouvet, Knowledge and Innovation Facilitator at Agri-TechE. Today we'll be discussing carbon sequestration and soil degradation with Gareth from Cambond and Brian from the University of East Anglia. Brian, if you could introduce yourself and what you do at a UEA and what you'd like to bring into the hub today.
Thank you, Laura. Thank you for the invitation to be part of the discussion today. I'm Professor of Soil Science at the University of East Anglia. I'm very interested about soil carbon, which we'll come back to talk about some more. I'm here sort of in the Innovation Hub to talk a bit more specifically about a project we have running, which is concerned with adding paper crumble materials to soil and looking at how those amendments change soil carbon stocks, but also change the properties of soils and allow soils maybe to function at a better level.
Okay, that's great, Brian. Gareth, can you tell us a bit more about what you do and the sort of topics you want to talk about in the Innovation Hub today?
Hi, so I'm Gareth Roberts from Cambond, and we're a sustainable materials company. We're interested in the materials that people use for construction and everyday products. How can we alter the formulation of those materials to make them, one, more sustainable, two, a lower carbon footprint, and three, and perhaps one of the most important things, is the same cost or ideally even cheaper than the materials we currently use. We found that we could use a very common material called distillers dried grains and solutes, DDGS. That's the stuff you get from whiskey distillation or from bioethanol manufacturing. So this is available in very large quantities in the UK, about 1.5 million tonnes produced every year. It's a very common animal feed additive, and it's available in bulk all around the world. Well, we found in a very simple procedure, we can turn that into a glue so that you can replace urea formaldehyde resins to make things like plywoods, MDF and particle boards. So not only do you have something that's plant-based and low carbon, you take away the toxicity, it can actually be the same cost as urea formaldehyde, but more importantly, every product that you make with it has a lower carbon footprint.
It's a great concept, isn't it? And the fact that all of this is the byproducts is, like you said, cheaply and readily available. It's almost, you know, you've got something quite innovative in the way that you're developing this resin and going about developing those biocomposites, and the fact that it's market ready and can have a huge impact, and is already having a huge impact. So that's fantastic. Brian, I wondered whether you could tell us a bit more about the actual role of carbon. Why do we need it in the soil? What does it do? As part of the whole equation, why is it so important?
Yeah, so I think we've seen a lot of technology being developed around ways of preparing seedbeds in a low impact way, so minimum till sort of technologies. And it really goes back to the fundamentals that I began with, that if you allow lots of air and oxygen to interact with your soil, the carbon degrades and is lost to the atmosphere. So we've seen a lot of technology go into ways of preparing seedbeds so that doesn't happen, and to protect the soil carbon store, which is already there. Relevant at this time is, of course, the NFU's aspiration for net zero farming by 2040. And within that, there's sort of 3 pillars that they're concerned with. And one of those pillars is about direct soil carbon storage. And the NFU report that I referred to suggests that probably about a quarter of the net zero ambition can be realised through soil-based carbon measures. The other 2 pillars within the net zero framing are to do with the actual energy and carbon footprint of doing the agriculture, and to that relate to emissions from livestock primarily. So the NFU is looking across all three of those pillars to try and make those carbon reductions and achieve a net zero footprint for the agricultural system. I mean, it's worth pointing out that in the UK, probably about 10% of our carbon footprint is from agriculture. And in other parts of the world, where maybe they have less industry and more farming, that number could be as high as maybe 30%.
So this paper crumble that you talked about as a byproduct, you've used it in your research, but I think it's not something that's new to farmers, is it? Farmers have used it historically to improve their soil conditions. So I wondered if you could tell us a bit more about that and what's innovative in the research that you found and how it improves carbon sequestration as well.
Yeah, of course. So previous work relating to paper crumble application to soil is focused quite a lot around how paper crumble changes water retention within the soil. So paper is absorbent and that helps to store water. But in addition to that, the paper also interacts with the soil. It helps to structure the soil and to change its density. So generally when you add paper to soil, it improves the aggregation of the particles. And that decreases the density of the soil, which kind of means in reverse that there's more pore space within the soil. And that pore space allows more water to be stored. And that pretty much has been the motivator to use paper crumble as a soil improver to improve the physical structure of the soil. But if we sort of fast forward to now, there's a lot more interest in carbon. So we're kind of seeing the opportunity to take high carbon materials, which, if you think about paper as a material, was formed through the sort of natural cycle of plants removing carbon dioxide from the atmosphere, forming their tissues, and then that woody material getting used to produce paper, and then that paper being recycled, and then the paper crumble being produced. So we have a material which has actually removed carbon from the atmosphere, which we're now seeking to bury in the land, and in effect to transfer the carbon that was in the atmosphere back into the soil.
And making sure that loop is continuous, I think.
Yeah, very much so. I think it's important for people to appreciate, and I'm sure a lot of people do, that there is this cycle, a natural cycle where plants remove carbon dioxide and then the plants die and they degrade and that carbon is released back up into the atmosphere. And that cycle was, very much in equilibrium if we go back maybe 150 years when there was less people pressure on the planet and the land wasn't being used as intensively. But kind of the issues unfolded over the last century and a half as we've cleared more and more forest and so lost the forest carbon, but we've also lost the soil carbon from within those forests. And that carbon is now in the atmosphere and it's fueling the climate change that we see. And that natural flux through interaction with people, clearing the land and working the land, has made a significant contribution alongside the fossil fuel contribution, which we're much more familiar with.
Wood, it's an interesting issue. Yes, it's sustainable, but it does take a while to grow wood. And then if people are just chopping it down and sometimes using it, the product that they're making has a very short lifespan. One of the things I'm thinking of is wooden pallets, which some of them are a one-way trip. So what people might not be aware of is half the wood in the United States goes into making wooden pallets. Okay, so it's a huge volume of things in just a simple product. And again, where we've replaced the wood then to move to something that has a very low or even a negative carbon footprint, we can begin to explain the concept that actually by using these byproducts, using a plant-based resin, you've got the world's cheapest and simplest carbon capture technology. So those materials that have a short half-life where they capture carbon from the sun and the atmosphere, they would then release it because they are put back in the ground or burned or otherwise wasted. If you lock them up as a board in a building for 30, 40 years, then they actually become a carbon sink. And then we can show people examples of resin, biomass and plastic composites. and using not only virgin polymers, but biodegradable polymers, and also in the more recent work, recycled plastics or reclaimed plastics. So that, again, a lot of the plastic that might go to landfill that you see as a problem, you can integrate with other byproducts and turn them into useful plastic products with a lower carbon footprint. And of course, you're saving material from being wasted in landfill or being burnt for energy.
Yeah, I mean, I think we've gone through a cycle which has been hugely beneficial for the planet about decarbonising our economies to try and cut down on fossil fuels and energy intensive processes to try and stop the release of carbon dioxide. And we've kind of reached the point where that decarbonisation is done a lot and it's becoming more and more difficult to realise advances. And so now the gaze has moved to the natural system, so nature-based solutions I think might be considered. And as I've highlighted, we've lost a lot of carbon from soil. So the opportunity to redress that and bring the carbon back into the soil, either through land management practices or soil carbon amendments or reforestation, all of those processes provide that opportunity to get back into the soil the carbon that's been lost historically.
Okay, that's great, Brian. Going back to the paper crumbles, the byproduct, is that something that is readily available? Would that be a cheap source of soil amendments for farmers to use? You know, what could be the business model around that for farmers to implement that on their farms?
To sort of answer your question, there is an established market for paper crumble materials. They're deployed to agricultural land under licence from the Environment Agency, and it's a widely adopted practice. I think that will continue to be the case. And as we move more and more to thinking about the services provided by land and the opportunity to build soil carbon stocks as a public good, I think we might see a shift in policy where agricultural payment mechanisms and levers start to think a bit more sophisticated about how payments for soil carbon or payment for soil services would be a way to encourage the application of high carbon materials, which fundamentally offset our carbon footprint, but also bring these benefits, wider benefits to the soil system. I think that's how the landscape is likely to shift as we go through the development of the new agricultural bill, and how ELMS, the Environmental Land Management System, provides mechanisms with farmers to engage through to realise payments which ultimately are going to be linked to these goods and services rather than just the action per se.
No, that's really interesting. There's definitely a bigger emphasis on that from all angles, I guess, you know, with the research that you're doing, but as well on the government and policy level. Taking a sideline into what it's like to build a business with sustainability at the heart of it, Gareth, can you tell us more about your journey to commercialisation at Cambond?
We learned a few hard lessons in talking to people.
Okay.
We started with a more complex technology and a more complex approach, and then rapidly got told by people in the industry that actually anything that was likely to cost more or require specific tools, in effect, was going to be almost impossible to take to market, because people just don't have the money to spend on that. So they're willing to listen to a solution, if you like, that appeals to the pocket. But the more moral pitch that, you know, this is just better for the planet.
Okay. Well, I guess if we could perhaps go back to one of the products that you've been developing, and quite an interesting example of how you're squaring the circle with the Camp Cup. Could you tell us a bit more about that, how the idea came about and where the project is at?
So one of the problems with developing a new technology is you have to take people by the hand and show them how they could use it and why it might be a benefit to them. And with ours, it's quite a general platform. We need a specific example. And in the last couple of years, we've looked at the coffee industry, mainly because it's attracted a huge amount of press and negative stories. So when you look at the coffee shop industry in the UK, they've got two strands of problem. One is the coffee itself, used coffee. What do you do with it? Coffee shops produce 500,000 tonnes a year of used coffee grounds. That's quite a lot of material. Essentially, the bulk of it goes into landfill. The other side of the equation is the cups that people use and take away. I think we all laboured under the misapprehension that these would be recycled, but it turns out they're made of a paper plastic composite that's difficult to recycle. So essentially they all ended up in landfill as well. So we decided to see, by applying our technology, let's look at both sides of the problem and see what we could do. The first was with the used coffee. If we think of that in very simple terms of it's just dry biomass, okay, the used coffee grounds. Well, we could take our resin, we could take a plastic or a different kinds of polymer with the coffee, put all that together, and we can make a bioplastic composite that then we can put through an injection molding system. And we made some of the world's first reusable coffee cups made from used coffee. Then the other side of the equation, the cups, we found that we could process the cups by chipping them and shredding them, again adding straw and our resin, and then you could press that and make a board, and the board could be used for furniture. So in theory, you could take the waste streams from the coffee industry, you could make the cups, reusable cups that your customers would need for your product by using the coffee grounds, and you could fit out your cafe by using the cup, disposable cups, and turning them into board for making the furniture, the countertops, and various other things. And we use that as an example of the kind of approach that you could go so that you deal with the problem people have and you make the whole enterprise more cost effective and more sustainable in the long run.
And I guess perhaps further down the line, what do you think would be your next byproduct that you'd like to use?
Well, we're looking at developing a concept we call Anthropocene mining.
Ooh.
Okay, so people are now becoming aware this label people use about we live in the Anthropocene age. So humans now have enough technology, we've been around long enough, we've made significant changes to the planet, both its climate and the physical structure with quarrying, mining and everything else. We've left traces all over the planet. This has resulted in huge amounts of waste materials. Okay, and a lot of that has just been landfilled or dumped in particular places. So we are interested in, if you think of it not as a dump, but as a mine of material, in the same way that people would go gold mining or lithium mining, can we mine ash from old power stations and use that as a basis for making construction products or other materials?
Oh, I think that's a really powerful concept, seeing landfills and agricultural byproducts as a gold mine. I think that's a great concept moving forward. A question that came to mind, Brian, you're researching paper crumbles and you're investigating the properties of that for carbon sequestration. Have you looked at other byproducts, such as those coming from wood, for example, anything that contains carbon? Is that something you've looked at?
Yeah, so previously I've done quite a lot of research around compost materials.
Oh, yes.
So I've got a whole part of my research which concerns itself with degradation of pollutants, so oils and hydrocarbons. And so compost is a really dynamic material which is super active, and the microbes that live in there are really good at breaking down really difficult molecules like bits of wood, as you point out. So we've done a whole raft of research around petrochemicals, fuels, oils, pesticides, those sorts of things, and how compost can help to degrade those. I mentioned earlier some modelling work we're doing around the paper crumble. So we've been benchmarking how persistent the paper carbon is against how persistent other carbon residues are. So in that work, we've been looking at plant residues, which are a common rework material into the soil. And we're seeing paper crumble offering, there's 10% more carbon after 10 years when we look at paper crumble compared with plant residues. Okay. And the reason for that is that the paper is already processed and it's quite a resilient material, whereas plants are full of lots of molecules which are quite easy to break down and degrade. And so taking a more recalcitrant carbon, a more robust, stronger carbon material, provides the opportunity for longer term carbon storage.
Okay, that's quite interesting then. Are there any other residues that you'd like to do research on?
I'm quite interested actually in plastics in an agricultural setting. This kind of links the two parts of what I've spoken about together. So plastics are a pollution problem. We don't really want them in our environment, and they're also a carbon material which could potentially be degraded. So I'm actually quite interested, given the way the landscape is at the moment, to look at biodegradable plastics and how they dissipate in the soil, how they break down and what happens to them. There's a lot of application of plastic mulch material to encourage crops to establish and to grow, and a lot of that plastic just ends up in the field. So yeah, I think there's real opportunity to look at other parts of the agricultural system which put carbon into the soil, either as a beneficial resource to stimulate the soil ecology, but also from the other side where you might have plastics which represent a bit more of a problem.
Okay, that's great, Brian. I guess we'll leave the discussion there. Gareth, what would be your take-home messages with regards to what Cambond is doing?
That we are reformulating material so that they can actually behave in a more sustainable way. They can reduce the carbon, help mitigate the impact of climate change, but actually you can do that and carry on doing everything that you do in it almost exactly the same way.
Oh, that's great, Gareth. I think that's a nice take-home message for people, and a good opportunity to give them food for thought. Thank you very much for joining us today. We hope you enjoyed the discussion. It was really interesting to hear about what Gareth and Brian are doing in their respective industries. And if you do want to find out more, they have a lot more content on their exhibitor page within the Innovation Hub. So do make sure to have a browse. If the discussion has sparked some questions for you, then there is an opportunity to ask those questions within their individual exhibitor pages. Thank you very much for joining us today.